All right, let's get right into this because it's a fascinating story. Imagine you're running one of India's largest stockbrokers. Every single day, you've got this massive, legally required job that you have to get done. But this isn't just any old task. We're talking about an operation so huge it was starting to creak at the seams, threatening to grind the whole system to a halt. This is how Zerodha's engineers took on that challenge and absolutely crushed it. First, just get your head around the scale of this thing. Every single day after the markets close, Zerodha has to generate and email over 1.5 million PDF reports. These are called contract notes, and they're not just simple receipts. They're super detailed legal documents that break down every single trade a person made. And the law says they have to be sent out before the next trading day. No excuses. And here's where the real pressure was building. Their old system, even after a bunch of upgrades over the years, was taking a full 8 hours to finish the job. 8! I mean, that's an entire workday. On a busy trading day, it took even longer, and sometimes the data from the exchanges would arrive late, squeezing that window even tighter. This wasn't just an inconvenience, it was a serious business risk. Something had to change.
And this is what they achieved. They took that 8-hour marathon and turned it into a 25-minute sprint. Let that sink in. That's not just a little bit faster, it's almost 20 times faster. They didn't just patch the problem, they completely re-engineered what was even possible.
So, the big question is how on earth did they do it? How do you take this monstrous 8-hour process and shrink it down to just 25 minutes? Well, it wasn't one magic trick. It was a whole series of really smart engineering choices, and it all started by throwing out the old playbook and rethinking the entire architecture from the ground up. Let's break it down.
So, before we can appreciate the new solution, we've really got to understand what was so broken about the old way. As Zerodha just kept growing and growing, their legacy system was really starting to buckle.
And the main culprit, the heart of the problem, was this. Everything was running on one single, big, powerful server. I mean, think about that. You have a task that is perfect for doing things in parallel, generating millions of separate reports, and it was all being forced down one single narrow pipeline. A Python script would create some HTML, a full Chrome browser would then print that HTML to a PDF, and a Java tool would sign it. Every single report had to wait its turn. Okay, so the team's first big move was a total shift in strategy. They realized that instead of trying to build an even bigger, more powerful single server, they should use an entire fleet of smaller, coordinated servers. This is the classic, brilliant move from vertical scaling to horizontal scaling. And this little chart explains the difference perfectly. The old way, vertical scaling, is like trying to make one single truck bigger and faster and stronger. You spend a ton of money, and eventually you just can't make it any bigger. The new way, horizontal scaling, is like using a whole fleet of regular trucks. Need more power? Just add more trucks. For a job like this, with 1.5 million separate tasks, it's a no-brainer. All right, with that new fleet strategy in mind, they went after the biggest performance hog in the whole system, the PDF generation itself. I mean, using an entire web browser, Chrome, just to save a file as a PDF? It's like using a sledgehammer to crack a nut. It's incredibly slow and eats up a ton of resources. They needed something way, way leaner. And their search for the right tool is a great little story in itself. They started by swapping out the browser for a tool called LaTeX, which instantly gave them a massive 10 times speed boost. Awesome, right? Well, not quite. It had a fatal flaw. On really big reports, it would just run out of memory and crash. And that's when they found the real breakthrough, this modern, super efficient tool called Typst. And just look at this difference. It's absolutely night and day. They did a stress test on a huge 2,000-page report. The best version of LaTeX took 18 minutes to create the PDF. Typst did the exact same job in 1 minute. One. That's not just an improvement, that is a revolutionary leap in performance. This was the key. But, it wasn't just the raw speed that made Typst the winner. It was also just better to work with. It's a single tiny file, which means the software containers they used were much smaller, so new servers could start up way faster. Plus, it gave clear error messages, which makes developers' lives so much easier. So it was a total win-win, better for the machines and better for the humans writing the code. So now they've got this lightning-fast PDF generator, everything's humming along, and then, bam, they hit another wall. Their code was now so fast that their storage system couldn't keep up. They were generating 7 million temporary files, and the system was choking on trying to read and write them all. So the problem was a bit technical, but the effect was like a massive traffic jam. The way they were naming their files meant that almost all of them started with the same few letters.
And deep inside Amazon S3, their cloud storage, files are organized into partitions based on those first few letters. So you had millions of requests trying to cram into the same tiny partition. It was like a 10-lane highway suddenly merging into one single toll booth. Total gridlock.
And the solution was just so simple it's brilliant. Instead of those random-looking file names, they just started naming them with 10 fixed prefixes, like 1 PDFs, 2 PDFs, and so on. This simple trick forced S3 to open up 10 parallel lanes from the get-go. And just like that, the traffic jam disappeared. Problem solved. Okay, so we have super fast computers and super fast storage. The final piece of the puzzle is coordination. How do you actually manage this temporary army of 40 servers that pop into existence, do their job, and then vanish, all in under half an hour? Well, you need a conductor for this digital orchestra.
And for Zerodha, that conductor is a tool called Nomad. You can think of it like an air traffic controller for all their software. It's the brain that tells the PDF creators, the digital signers, and the emailers exactly which server to run on and when. They chose it because they knew it well, and it's a bit simpler to manage than some of the bigger alternatives out there like Kubernetes.
The whole workflow is just a beautiful piece of automation. One server kicks the whole thing off. Then, a tool called Terraform automatically builds that entire 40-server cluster from scratch. Nomad jumps in and deploys all the little worker programs. A super-fast database called Redis acts like a central to-do list, and all the workers just grab the next job from the list. It's this incredible parallel system that just chews through 1.5 million reports at an unbelievable pace.
And all of that clever engineering is what leads to that incredible 25-minute result. But you know, the story isn't quite over when that last PDF gets sent. In my opinion, one of the most elegant parts of this whole system is what happens next.
This quote from their tech blog really says it all. The whole philosophy is show up, hit the problem with overwhelming force, saturate every bit of computing power you have, get the job done, and then just disappear. It's all about maximum efficiency for a very short, intense burst.
And here's how they pull off that vanishing act. A little program just sits there watching the to-do list. The second that number hits 0, it triggers the shutdown, the number of servers is set to 0, and Terraform comes back in and completely destroys the entire cluster it just built. So you have 25 minutes of intense work, and then poof, it's all gone. Incredibly efficient, and it means they only pay for exactly what they use.
You know, what Zerodha pulled off here is so much more than just a technical fix. It's a masterclass in first principles thinking. They looked at a giant, scary, monolithic problem and had the insight to break it down into millions of tiny, independent pieces that could all be solved at the same time. And it really makes you wonder, doesn't it? What seemingly impossible 8-hour task in your world is just a parallel processing problem waiting for a new blueprint.